Hello everyone, I am B. Malesh Kumar from Coastal Engineering College, Sivasi. This is my first internship on embedded systems at Yamatex Information Technologies, Bangalore. This is my project washing machine simulation on picsimlab. Here we go. This is our agenda about the organization, about C languages and embedded systems, tools required, implementation, result. Here we go. Next, about the organization, right? Yamatex Information Technologies Private Limited is a pioneer institute in India for embedded systems, Linux and IoT training, located in Bangalore since 2003. Yamatex has established itself as a top player in the field of real-time Linux and computer software training. Situated on MG Road, Bangalore, it serves as the one-step destination for learners from both within the city and across other regions. Over the years, it has built a strong reputation in the industry. Their commitment to the customer satisfaction, alongside the quality of their products and services, has helped them cultivate a growing and loyal customer base. Next, introduction to C programming. C is a versatile programming language. It was initially developed by Dennis Ritchie in the year of 1972. It was mainly developed as a system programming language to write an operating system. The main features of the C language include low-level memory access, a simple set of keywords, and a clean style. These features make C language suitable for systems programming like an operating system or compiler development. C programming is used in system software development, embedded software development, OS kernel development, firmware, middleware, and driver development, file system development, and many more. Embedded C is an extension of C language and it is used to develop microcontroller based applications. The extensions in the embedded C language from normal C programming is the input output hardware addressing, fixed point arithmetic operations, accessing address spaces, etc. Next, flow of a C program. Next, the flow of the C program contains documentation section, preprocess statement section, global declaration section, main code section, subfunction section. Here in the right side it's an example. My first code, the command line is the documented section. Next, hash defined by 3.14. It is a preprocess statement section. Next, hash include. This is a header file section. Int main. This is the start of the program. Inside this, the printf hello world session is a main code. Next, return 0 is the program termination. This is the flow of the C program. Next, the list of things that I learned in embedded C. First, keywords. Example, int for while. Int, it is used to represent the integer. For and while is used to represent the loops. Number systems. Here I studied the decimal, octal, hexadecimal, binary. Data representation. Here we represent the data in the form of bit, byte, and word. Basic data types. Integral, char, integer, floating point, inside, float, double. Integral, integer, both are used to represent the integers. Character, it is used to represent the characters. Floating point, it is used to display the pointing values. Double, it is used to display the large pointing values. Data modifiers, based on the size and sign, data modifiers are classified into two types. Size, signness. In the size, it has short, long, long. In the sign, it has signed and unsigned. Next, we studied about array, pointers, functions, string, memory segments, preprocessors. Array, it is a continuous storage of the elements in which the content is stored. Pointers, it is used to point to the address of the next variable. Functions, it is used to promote the code reusability. Strings, collection of characters is called as strings. Here we use the strings. Next, memory segments. In which memory segment which part of the value is stored. For preprocessors, in the above example, we saw about hash include stdio.h. has defined pi.h. These are all preprocessors. Next, conditional constructs. Conditional construct means for a particular situation we have to decide for this situation this decision is correct or this decision is correct. Based on this, it has single iteration or multi iteration. Single iteration means if and else family switch case. Next, multi iteration means for while do while do. Operators. Arithmetic, logical, relational, bitwise. Arithmetic operators are normal steps like addition, subtraction, multiplication, division, modulus, etc. Logical means logical and, logical or, logical not. Relational means um, equal to, not equal to, less than, greater than. Less than equal to, greater than equal to. Bitwise means bitwise and, bitwise or, bitwise not, um, bitwise left shift operator, bitwise right shift operator, etc. Next, introduction to the embedded systems. An embedded system, it is a microprocessor and microcontroller based system of hardware and software designed to perform the dedicated functions within a larger mechanical or electrical system. Categories of the embedded system: standalone embedded system, real-time embedded system, networked embedded system, mobile embedded system, hybrid embedded system. Based on the standalone embedded system, they are classified into two types: slave embedded system, independent embedded system. Slave embedded system is semi-automated. Independent means fully automated. Next, here the components and requirements. For components, I need a software, I need a microcontroller, I need a digital to analog converter, analog to digital converter. For running this, I must need a human interface and a diagnostic port. Here I need actuators and sensors to sense the temperature. I also need auxiliary system for powering and cooling. Here I also need memory and SGPA. For a product, for a well-versed product, these are the requirements. It must be reliable, cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. Next, these are the challenges: development and common design matrices for designing and developing a project. For challenges, efficient input and output systems. For efficient input, it must give the efficient output. For developing a project, we have to embed it on OS. It must be a challenge. For developing a project, we have to write the code in a very optimized manner. For writing each code and each module, we have to test and debug it. It must be safe, and we have to maintain that code, maintain that product. That product must be flexible to uh, all the situations, at the extreme situation also. Development. For developing a project, I need the processor, memory, operating systems, programming languages. Here you use embedded C and development tools. I have to follow this common design matrices like time to prototype, power, performance and correctness, size, NRE, non-recurring engineering cost, unit cost, time to market. Next, microcontroller. It is an integrated circuit which is capable of being programmed to perform a specific task. The design normally has restrictions on its memory size, input-output capabilities, peripheral functions, etc. Before select a microcontroller application, we have to think these in mind. First, performance, price, availability of the product in your region, availability of tools for developing a project in your region, special capabilities. Next, difference between microprocessor and microcontroller. Microprocessor, it has all separate components. It has no inbuilt components. If I need to integrate a LED or a timer or a buzzer with the microprocessor, means I need to externally integrate it from outside. It is more flexible, but it has more design complexity. But in a microcontroller, all the components in a single chip, timer, LED, buzzer, all are in a single chip. It is less flexible, it has less design complexity. Next, introduction to our project. A washing machine. A washing machine, also known as laundry machine, clothes washer, or simply a washer, is a home appliance used to wash laundry. The term typically refers to the machine that uses water as opposite to dry cleaning, which uses alternative cleaning fluids and is performed by specialized businesses or ultrasonic sensor. The user adds laundry agent available in liquid or powder form to the wash water. Washing machines contain a barrel into which cloths are placed. This barrel is filled with water and then rotated at high speed, allowing the water and detergent to remove dirt from the cloths. Most washing machines are designed with dispensers or detergents, liquid or powder, to aid in the cleaning process. Washing machines plays a very important role in modern society. They help save human labor, time and energy. There are various types of washing machine, each offering different features and modes of operation. Project overview. In this internship project, we implemented a washing machine control system using PIC16F877A microcontroller. Microcontroller specifications. Bus width 8 bits, pin count 40 pins, among this STAT3 are input-output pins, program memory 1.43 kilobytes, CPU speed 5 million instructions per second, RAM size 368 bytes, EEPROM size 256 bytes. Ports in PIC16 F877A. The PIC16 F877A microcontroller consists of 5 ports. Port a 6-bit port configurable as input or output based on the status of TRISC register. Port B, an 8-bit port usable as both input and output. Port C, an 8-bit port input or output configuration depends on the TRISC register. Port D, also an 8-bit port typically used for LCD interfacing and general purpose I/O. Port E, a 3-bit port often used for analog input. This microcontroller is well suitable for embedded system applications like washing machine due to its reliability, speed and ease of programming. Next, architecture. The architecture of PIC16 F877O consists of GPIO, EEPROM, LM35. It is a temperature sensor used to sense the temperature, ADC, analog to digital converter, RS232, LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD. Next, this is the architecture of the PIC16 F877A. Next, software tools used. MPLab X IDE version 5.50, X8 compiler, picsimlab. MPLab X IDE version 5.50 is used to write the code. X8 compiler is used to compile the written code and generate the hex file. Picsimlab is used to load the hex file and simulate our output. Next, these are the modes in washing machine and are the water levels in washing machine. Daily, heavy, delicates, whites, stain wash, eco cottons, woolen, bed sheets, rinse plus dry, dry only, wash only, Akastu. Next, water levels, low, medium, max, auto. Next, this is our PIC16 F877A microcontroller. Here the main 4 parts. The door is connected to RB0, key 4 it is connected to RB3, key 5 it is connected to RB4, key 6 is connected to RB5. Next, implementation. As soon as we power on the washing machine or the microcontroller, we want simulator to display the message for the user like press key 5 to power on washing machine. Once the simulator displays the message for the user, then the user press key 5 for further process. After pressing the key 5, the controller starts again. It displays the message for the user like powering on washing machine. Then the CLCD shows all the different washing programs like daily, heavy, delicate, eco cottons, dry only and many more etc. Simulator contains a digital key or the tactile switch. With the help of it, the user can able to choose the respect programs by scroll down with the help of switch 4. The user has to long press the key 4 to select the program. Then it moves to the next stage. After selecting the washing programs, then the CLCD displays the different water levels. The user can select the particular water levels required by the washing programs. Even in this, the CLCD displays the water levels like auto, low, medium, high and max. Similarly, the user can scroll down the select water levels by long pressing the switch 4. The user can select the water levels. After selecting the water levels, the CLCD displays the message. Press switch 5 to start, switch 6 to stop. If the user press the switch 6 to stop the program, Then it returns to the washing programs. If the user press the switch 5, that is to start the program, then it displays the user about the selected program. The CLCD displays the particular program and time to watch the selected program in minutes and seconds. Then the machine starts to run. At the same time, the motor, fan or rotor rotates and it will be showing the remaining time to complete. Even the program shows whether the cloths are washing or rinsing or spinning. CLCD displays 5 to start and 6 to pause. If the user press the switch 6 to pause, then the washing machine stops, even the time stops and even the motor stops rotating. Again, if the user press switch 5, then again the washing starts and the rotor begins to rotate. If the switch 1 is not pressed, then it indicates that the washing machine door is closed. If the switch 1 is pressed, then it indicates the door is opened. If the user pressed the switch 1, then the buzzer turns on to indicate the door is open. At the time of washing, the user opens the door by pressing the switch 1 or B0. Then the CLCD displays the message like door open, please close. When the washing is completed and when the time returns to 0, then the rotor stops and the buzzer turns on indicating the program is ended. You can take off your clothes back. After finishing, it displays program completed, remove clothes. Then at last, it again comes back to the washing program display. Next, this is our project implementation. First, we have to press key 5 to power on washing machine. It will be displayed in the CLCD. First start. I have to click RB4. It displays all the washing machine programs like heavy, daily, heavy, delicates, etc. If I press RB3 to scroll and select our washing programs. For each clicking RB3, it will scroll and display the washing programs. Now I select the Eco Cottons and press long press RB3. Now my program is selected and it also displays the water level. Now we also, by clicking the RB3, we can scroll down the water levels. After long pressing RB3, we can select the max water level. Here I select the max water level. After selecting the water level, it displays press switch 5 to start, switch 6 to stop. By long pressly clicking it, switch 5 to start, by long press clicking switch 6 to stop. Here I click long press switch 5 to start. Long pressing it, keep trying until your output comes. Keep trying until your output comes. Next, if I select it, my program name is Eco Cottons. It has a time of 0 minutes and 36 seconds. Now it starts running. It also first sorry for the inconvenience. Now we start with press switch. By long pressingly clicking the RB4 to move to the next step. Okay. Yes. After clicking it, it displays program echo cottons time 0 minutes 36 seconds. Next. It also displays first function was time this, press 5 to start, press 6 to pause. Next. Now the machine is running. Now the machine is running. If I click RB0 button means it displays door open, please close. And the buzzer is also buzzering. After I releasing this RB0 button, the buzzer stops buzzering and our normal function happens. First wash is going to happen. After finishing wash, rinse is happening. After finishing rinse, spin is happening. After finishing, totally the buzzer is buzzing and it displays wash completed, take your clocks. And it finally displays two washing program details. This is the project successfully, this is how the project is successfully implemented. Next. This is the result screen. First, it displays press key 5 to power on washing machine. Next, it displays powering on washing machine. Next, it displays the different washing screens, washing program screens. Next, it displays the water level. Next, it displays press switch button. Next, it displays programming details. Next, it displays what are the functions happen. Next, finally, it displays program completed, remove clocks. Next, finally, I hopefully thank Emertex for successfully giving me this opportunity. I hope I successfully implemented this project. Thank you for Emertex for giving me this opportunity. Thank you.